Here we are going to monitor our progress and we're going to model with some mathematics. Okay, here in this exercise, you're going to find the degree of these monomials. Here I only have 4 problems, 5, 7, 9, and 11. And if you need help on this, please look back at example 1's video. Okay, so let's look at the degree here. So the highest degree here is a 1, so we call this a degree 1. Here the exponent here is a 2, so we call this a degree 2, right? What about this one? Oop, there's a 1 here, so it's 8 plus 1 becomes 9, so the degree of this monomial is a degree 9. Here you have 1 that is above the x, a 3 that is above the y, and a 7 above the z. So 1 plus 3 plus 7 is plus 3 is 11. So the degree here should be 11. Next, in this exercise, you're going to write the polynomial in standard form, and you're going to identify. So again, first thing, standard form. Then you're going to identify leading coefficient as well as the degree, and then classify the term. All right. So let's take a look. Is this in standard form? No. What goes first? The highest degree. So the 2c4. So 2c4 is the highest monomial. Then we have the plus 6z squared minus c. Okay, this is how it looks like in standard form. The degree here is 4. The leading, I'm just going to write LC as leading coefficient. Leading coefficient here is 2, and this is 3 terms, so this is called a trinomial. Okay, next one, 7 plus 3p squared. Okay, rewrite this so it becomes 3p squared because again that is highest degree plus 7, which is the constant. So the degree here is going to be equal to 2. Leading coefficient is the number in front of the variable, which is a 3. And this has 1, 2 terms, so this is called a binomial. Here we have a t to the 8th power, so it's just 3t8. The degree is equal to 8. The leading coefficient is 3, and this is a monomial. Okay. Ooh, this is very hard. Okay. Highest power is the 8, so negative 5 over 7 r to the 8th power plus, pi r squared plus 2r squared. Ooh, I think that becomes 2 pi r second power, right? If we combine them. So the degree here is still 8. This is the leading coefficient is a negative 5 over 7, and this is a binomial. Okay, if you know how to do the first 3, you're good. 19 is just a more advanced question. Okay, here the next exercise. In this exercise, you're going to find the sum of each term. Can I do this right here? Yeah, I think I have room. All right, so let's do it. Find the sum. All right, so this and this, okay, will go together. Right? So this is going to become, let's see, 5y minus 2y plus, then we have the 4 and the 6. 4 plus 6. So 5y minus 2y becomes 3y plus 4 plus 6 becomes 10. There you go. Next, okay, this is the xn squared, which is the second degree. Fits with that one. So that's 2n squared minus n squared plus this term is the first degree. So that is your negative 5n minus 3n. Then your last term, negative 6 plus 11. negative 6 plus 11. Okay, 2n squared minus n squared just becomes a n squared. You could write a 1 here if you want. 1n squared plus 5n minus 3n becomes negative 8n. The last one, negative 6 plus 11 becomes 6, 7, 8, 9, 10, 11 plus 5. Here, if you want to write it, it just becomes n squared minus 8n plus 5. Okay, the 1, it's not there. The negative 8, right there, negative 8. You don't have to write plus. Okay, next one, 3, 3g squared, 3g squared. So that goes together. So 3g squared plus 3g squared plus, you have a negative g plus an other negative 8g. So negative g plus, oops, that should be negative 8g and plus 4. All right. So this becomes 6g squared, 3 plus 3, right? And it's still second degree, plus negative g and negative 8g. That becomes a negative 9g and a plus 4. So that becomes 6g squared minus 9g plus 4. Is that right? Yep. Good. Find the difference. Now we're going to subtract. Okay. Here's the 1. Distribute that to all the terms. So you have d minus 9, let's see, minus 3d plus 1. Okay, so you have your d minus 3d plus negative 9 plus 1. Right, like what we did before. D minus 3d becomes negative 2d plus negative 8, 9 plus 1 becomes a negative 8. So that just becomes negative 2d minus 8. 33. Ooh, let's see if I have room. Okay. Again, there's a negative 1 that you want to distribute. So let me just write that. Here's the first expression. Negative 1 times 3y squared becomes a negative 3y squared. Negative 1 times negative 6y plus 6y. Negative 1 times negative 2 becomes a positive 9. All right. So y squared minus 4y plus 9, negative 3y squared. Oops, I didn't have to write this. Now we can just combine the terms. So I had what? Y squared minus 3y squared plus 6y minus 4y plus 9 plus 9. Okay, so what does this become? This becomes a negative 2y squared plus, what does this become? 2y. 9 plus 9 becomes a 8 plus 18. So this becomes, what's your answer? Negative 2y squared plus 2y plus 18. Okay, 35. I'm going to do number 35 right here. Okay, number 35. Right? So this is how it looks like. So here, let's just bring up paint for this one. I don't want to crowd the board. So k cubed minus 7k plus 2 minus k squared minus 12. All right. Remember, there's a negative 1 here that you're going to distribute. All right. So nothing happened here. So this is just k cubed minus 7k plus 2. All right. All right. Now it's going to be minus, because the negative 1 times k squared, negative k squared. Negative 1 times negative 12, so that's a positive 12. Okay. Now you want to group some terms here. You just have your x cubed plus, this is your second degree. So you had your negative 7k. Oh, no, nope, nope, nope. That's not right. Your second degree is this, right? So it's negative kx squared. Yep. Nothing happens to it, right? This is the third degree. This is your second degree. This is the first degree, and these are your constants, right? So this is your third degree. This is your second degree. Now we need our first degree. So it's going to be plus what? Negative 7k. Then you're going to have your plus your constant. Your constant here is 2 plus 12. So your answer is k cubed, which is your third degree, minus k squared, second degree, minus 7k, which is your first degree, plus your constant, 2 plus 12 becomes 14. Okay, this is a little bit harder because here you had 4 terms. All right. Okay, so I think that's it. Yep, there you go. Those are all how you add and subtract um, polynomials.